Hello everyone. For this video, let's talk about the tables that we can use for the binomial distribution. So if you look at the tables folder that we have on Blackboard, that we have two types of binomial table. So one is called binomial distribution table, and the other one is called binomial table, which is cumulative. And then for this video lecture, we're going to talk about the difference between these two tables, and then how can we use either one to check the values that we need. So let's start with a binomial distribution. For this one, let's toast coin for 5 times. And let x be the x observed. Okay, so if we toss a coin for 5 times, so we can get we possible have all 5 tails, right? So we can have no head, which is 0. We can have 1 head, and then the other 4 tails, or 2 heads, 3 heads, 4, 5. But we can never have 6 heads because altogether we toss a coin 5 times. So that's the possible value for x. And then we can have the corresponding probability. Take the value. So this is a binomial distribution. X follows a binomial distribution. We can check the binomial requirement. So tossing a coin all meets the binomial setup. So binomial n and p. So n is the fixed number of trials. So we toss the coin for 5 times. So n equals 5. What about the little p? Probability of success, right? In this case, we're focusing on heads observed. So that's probability of head. That is 5, since this is a fair coin. And then that's the binomial that we have, 5.5. Then we can actually have all the values calculated using the binomial probability mass function. So that is of x equals e to the power of x. So when we want to know probability 0, then that is 5 to 0, 5 to the 0, 5 to the 5. So 1 minus p, that's 0.5 to the 5. So 5 choose 0. So there's only one way that you choose nothing, right? So that equals 1. And 0.5 to 0, anything to the power of 0, that's 1. So 1 times 1 times this power. And we can use our calculator to calculate that to the 5th power. So that is 0.03125. Okay, and then probability of 1, that is 5 choose 1, 1, 0.5 to the 5 minus 1. 5 times 0.5. That is 0.15625. X equals 2, factors 2 to the power of 2, 0 0.5 to the power of 5 minus 2, that's 3. So that is 5 times 4 divided by 2, factors 2. That's how we calculate it. 0. So that's 10 times 0.3125. Power of x equals 3, factors 3 to the third power, 0.5 to the 5 minus 3, that's 2. So factors 3 is the same as factors 2. So still going to be 10, but let's write it down. 5 times 4 times 3 times 3 times 2. So, same thing, times 0.5 to the fifth power. We'll get the same number. X equals 4, 4, 5 to the fourth power, 0.5 to the 1. That is same as factors 1. So 5 times 0.5 to the power. So that gives us 0.15. X equals 5. That is factors 5. 0.5 to the power of 5. 0.5 to the power of 0 equals the factor 0. So 0.5 to the power 3, 1. So using the same formula, we got all probabilities calculated, and then we can fill them in to this discrete distribution setup. So we have take 1, when take 0, the probability is 0.03. So we let's write it in a column way. So and the value x can take 0, 1, 2, 3, 5 with the corresponding probability. So when little p equals 0.5, corresponding probability for x equals 0, that is 0.03125. For 1, 0.15625. 2, 0.3125. 3, 0.3125. 4, 0.15625. 5, 0.03125. Okay, so that is a discrete distribution, and then of course the sum of all the probabilities equals 1, and we call this the binomial table. So we can have unbalanced coin, right? Which means probably landing head, you can take a different probability than 0.5, and then we'll use the same way to calculate those probabilities, and then we have separate columns referring to the probability of success equals a different value for n equals 5. We can also make such table for n equals 10, and then we combine all possibilities together, and then that's our binomial table. So next time, if you want to look at binomial np n equals 5, p equals 0.5, we can just check the table. We don't have to calculate it anymore. So let's recall this numbers, remember these numbers, and then kind of look at it from the table we have. So we have n equals 5, right? And then p, that's the little p, probability of success equals 0.5. And then when n equals 5, x can take value 0 to 5. And then the probabilities are here: 0.031, 0.156, 0.312, 0.312, 0.156, 0.031. And then if we compare with the calculation we have, they're the same. So this is called the binomial distribution table. And what is the cumulative table? It's just on top of this binomial distribution table. If we put all the probabilities up to that x there, and you put those in a cumulative way, then that's called the binomial table, cumulative binomial table. So then just on top of this, we can write the values down. 0. Let's do it here. So we have 0.031. So that's up to this point, right? Up to x can take 0, then you have probability of 0.031. So when we consider 0 and 1, so that means up to 1 together. So you have two probabilities, right? Add up those. 0.031 plus 0.156, that gives us 0.187. And then up to 2. So the probabilities altogether equals 0.187 plus 0.312. 0.499. Then up to x can take 3, so 0, 1, 2, 3 altogether. That is 0.499 plus 0.312 to give us 0.1, and then one more, 0.811 plus 0.156, 0.967. And then for the last one, we should use 0.967 plus 0.031. So it's always going to be 1 because that's up to 5. What's the total? So probability added up together should be equals to 1. So let's remember those numbers and then compare with the table we have here, the binomial cumulative table. N equals 5, P equals 0.5. Then those are the values we have. So instead of using x, we use k. So k means up to that value. So when, let's say this value, 0.8125, k equals 3, that means probability of x equals 0 plus probability of x equals 1 plus probability of x equals 3. So those all together equals 0.8125. Then it's easy to convert this cumulative table back to the binomial probability table because we know 0.1875 is probability of 0 plus probability of 1. So if you get only probability of 1, that is probability of x smaller than or equals 1 minus 0. So 0.1875 minus 0.0313. So that'll give you probability of x equals 1. 0.1875 minus 0.0313, 0.1562. It's probability of x equals 1. We can verify that. 0.156. So same value. So either table, you can use either table. It'll be the same. It'll provide the same value. Okay, that's reading the binomial probability, binomial distribution table, and then the cumulative binomial table. Thanks for watching.